Quantum computing.
Addition into vector space and then multiplication with scalars, and then of course relies on the fact that we have a field of complex numbers where addition and multiplication are defined as well.
And if you're like me and that sounded like the first time you heard somebody speak a different language, awesome, you're in the right place, stick with me, we'll try to figure this out together. Quantum computers, the idea started in the 1980s when physicists like Richard Feynman and David Deutsch, nice, said if nature is quantum, maybe we should build computers that are quantum too. Just like if self-love is the answer, why does it feel like I'm gaslighting myself? Because it does. Anyway, at this point, it's pure speculation, intelligent farts in the wind. Now, fast forward 10 years, and we have the first quantum algorithms. In 1994, Peter Shor created an algorithm that could break large encryption codes faster than a standard computer. And in 1996, Love Grover, incredible name, created a faster search algorithm. It's 4 a.m. and I'm sitting on a generator. So it was like having a recipe before kitchens were a thing, or imagining a hoverboard, but all you have is a skateboard and saying, these wheels spin, helicopter rotors spin, maybe we can get this thing to fly. Which sounds crazy, but we do have hoverboards. Also, dude, what is even a qubit? Okay, wait, before we do that, let's try to figure out the two key elements that make quantum computers a real thing that's supposedly not magic. Superposition and entanglement, shit I don't understand for 200, please and thank you. Entanglement is the connection between two or more qubits where the state of one qubit instantly affects the other no matter how far apart they are. So it's just like dumping your childhood trauma on your friend in another state over the phone. Your depression gave him depression, quantum depression. But it's okay, you should talk about your trauma. Good friends will cry with you, not laugh at you. Superposition is where a qubit can exist in multiple states at once, 1, 0, or both, before it's measured. Once it's measured, it collapses to either a 1 or a 0. This before measured superposition state is what makes a quantum computer so powerful. Think of it as being fine and falling apart at the same time. And then when somebody asks how you're doing, you just say, I'm fine. Quantum existential dread. Also, these are the equations for superposition and entanglement. Brother, that's a trident.
Daddy, chill.
What the hell is even that?
I took trigonometry in high school, and that's all I remember, is that it was called trigonometry. I know there's letters in math equations, but I'm drawing the line at weapons from Greek mythology. That's actually called Dirac's notations, Ket, and it represents the quantum vector, which I don't understand and is useless information to me, like when your dad asks you for a wrench and you hand him a shovel.
You got a piece of cutter.
Back on track now. A standard computer runs on bits, ones and zeros, just like the Matrix. Now, bits are the smallest piece of information a computer can store. It's described as a light switch. It's either on or off. And when you put a gaggle of bits together, they can represent anything. Letters, numbers, entire video games, shout out Fallout. And when trying to figure out a problem like why my finger perforates through the toilet paper when wiping, a standard supercomputer can only test one reason at a time. Now, it does this with brute force and massive hardware power with hundreds of thousands to millions of CPU and GPU cores working together. Still one at a time, but it can do this incredibly fast. They are advanced, but like NASCAR, we want to go real fast and real left.
You gotta win to get love. Everyone knows that.
As for the toilet paper issue, operator error, I should probably cut my fingernails. Enter qubits, or quantum bits, that exploit these laws of quantum physics. A qubit can either be a 1 or a 0 or both at the same time, thanks to superposition. And in doing so, can test every possible solution at the same time at an incredible rate. Think a carousel, because my smooth brain can't picture it otherwise. As it spins, a standard computer is looking directly ahead and can only see the animal right in front of it, checking each one for damage, let's say. And as it spins, another animal, another test, and so on. Quantum computers can take that carousel and using a die grinder, cut it loose, lay it flat on the ground, and check every animal all at the same time. It's crazy and for sure magic. Now, explaining a qubit is cool and all, but I want to know what it is physically. I want to hold it in my hand and pet it. Qubits can be made a couple of ways. If it's by superconducting, they're in tiny circuits on chips made out of niobium, and the qubit is the current that flows clockwise, counterclockwise, or both. Also, superconducting, brother, is when a material like niobium, which for the record I didn't know existed until researching this, is cooled to 9.2 Kelvin. Don't know what that is? Me either. It's minus 443 degrees Fahrenheit or minus 263 degrees Celsius. How do you even do that? Magic. I'm telling you. Nope, a dilution refrigerator, which uses 2 isotopes of helium to absorb all the heat and cool the material in stages to a superconducting state.
What you smoking?
I'm not smoking. I'm breathing.
Awesome, but if I can't fit any popsicles or ice cream in it, it's useless. Being cooled then allows the electricity to flow infinitely without any resistance. Usually electrons are kind of bouncing all over the place, but in this state, they pair up in what's called a Cooper pair and flow in sync with each other. Like when you're playing pool, and since you won last game, you break. Regular electricity flowing is like breaking in pool. The electrons all have a destination, but they bounce off walls, they bounce off each other. Some make it to where they're supposed to go, and some just slow down due to the friction. Now, if superconducted, after the break, each ball would pair up and follow each other into the same pocket, no resistance, never slowing down. Pretty neat. Trapped ion qubits are made from a single charged atom in an electromagnetic field where lasers manipulate the ion's energy to represent either a 1 or 0 or both. How, you say? Scientists pick an atom like barium or calcium, strip away an electron, leaving it positively charged. They then use a Paul or Penning trap, which holds the ions in an electromagnetic field, levitating it in a vacuum. Makes sense? Not to me. I'm a mechanic. I'm trying to imagine where all of this started. How did we find out if you cooled a material to minus 443 degrees that it becomes superconducting? And how did we catch an atom? I can't catch mice in my shop, but we caught an atom using what? A quantum baseball glove, playing quantum beer pong, and a quantum red Solo cup. Got it.
Nice.
So where are we with this, right? Well, Google's Willow chip, 105 qubit superconducting processor, has officially been tested using random circuit sampling, which is basically a benchmark test that says this quantum computer can do this one thing faster than a supercomputer. It's basically just a bunch of instructions for a qubit to like rotate or flip in a sequence. It's not like some wild calculation, it's just a long, complicated sequence of things, and it tests how fast the computer can do it. How fast exactly? Well, Google's Willow chip finished this benchmark test in 5 minutes. Now, without context, that sounds like dial-up, or when you try to download your first nudie pics on your flip phone. No judgment here, we all did it. But when compared to the estimated time it would take a standard supercomputer to complete, 10 septillion years. I didn't know septillion existed as a number. It sounds like the snake lizard hybrid people that run our government. But as of right now, they make a lot of mistakes. 1/10 to 1%, which to me sounds really good, but apparently it's not. Because one error in one qubit will compound and eventually break the whole system due to them being in superposition and entanglement. Now, to self-correct like a standard supercomputer, you would need a ton of qubits, which costs a lot of money and requires a lot of infrastructure. Now, these mistakes actually come from the qubits losing their quantum state. Any interference from the environment, like heat or vibrations, induce these errors. It's like trying to balance a ball on your nose while somebody whispers sweet nothings into your ear and pokes you in the belly button.
Hey, how you doing, little mama? Let me whisper in your ear.
Now, this is insane, but all it does is essentially prove it can outrun a supercomputer. Think a Tesla Plaid racing a rock that isn't moving. But every once in a while, it veers off course, launching itself off of a cliff, landing on a yacht occupied by everybody on the list that doesn't exist anymore, exploding and fatally wounding everybody on board. It's very early testing, but it does bring up some wild conspiracies. Let's say AI keeps developing and the worries about it becoming super intelligent come true. It's full-on Matrix Terminator, war against human and machine. They get a hold of quantum computing, there's no hope for humanity. It would instantly crack all encryption, gaining access to every device on the planet. It could take control of the global infrastructure. It could simulate and predict every global event, catastrophe, riot, virus, and predict every human reaction possible. Free will becomes a statistical impossibility. We become puppets in a simulation if we aren't already in one. It's a simulation playing a simulation disguised as another simulation.
I know who I am. I'm a dude playing a dude disguised as another dude. What?
Same goes for countries. Whoever gets a hold of this essentially wins. It's the superpower of all superpowers and makes the Infinity Gauntlet a digital reality. Now, I know this is dystopian and possibly silly and never going to happen, but there are some incredible things that could happen with this technology. It could revolutionize medicine, creating drugs cheaper, cleaner, and faster at a molecular level, and tailor treatments to individual patients. Predict extreme weather events, give us ways to optimize our energy, unhackable quantum encryption, enable smarter AI, but simpler things as well, like planning, research and development. It could help create a toilet paper that your finger will never perforate through and takes Amazon Prime's 2-day shipping down to 2 hours, then 20 minutes until things can teleport directly into your home. I personally hope we can see some developments in our lifetime towards the positive side of things, but if I think too much of the dark side, a panic attack, a couple Xanax can't calm will ensue. I could go on and on trying to explain quantum computing to you and I, but I've already confused myself and have more questions than answers. It's an incredibly complex subject that fascinates me and genuinely seems impossible. But here we are. Google, IBM, Ionic, Microsoft, and many other companies are dumping incomprehensible amounts of money and energy into this, so I guarantee they know something we don't and are much closer than we think. Conspiracies are fun. That's all I can understand right now, and we're just scratching the surface. Anyway, if you're here listening to this, I appreciate your time. Thank you. It's been an honor having you here. Hopefully you enjoyed this. I'm trying to make this fun and entertaining and share my genuine curiosity about these really complex, confusing subjects. Learning about these subjects in real time and trying to explain it in a way that wouldn't confuse me more than life has confused me already. So with that said, thank you. I appreciate it. I hope you stick around for the next one. Well, at least now we know a qubit isn't just like a weird flavor of jelly beans.